Now I finished the last video a little short, but it's just a couple of references I wanted to draw your attention to. Of course we have the Unity documentation with the reference manual. We'll scroll down till we find some settings, and there was our render settings. Okay, so there's the Unity definitions. And of course with anything, you want to find out about search. Okay, so just using a simple search string like that is our online documentation. And a few people asking questions and talking about fog settings and ambience. And there's a video down here. So if you have a look at this video, it covers a lot better than I tried to. All the settings in the render settings and how to manipulate them and get them for a desired effect. Okay, so if you want to see something on people that play with this stuff every day, some experts that have experience, click over this video and hopefully they'll cover anything I've missed or wasn't clear about. Okay, now I'm so keen to rush on because I really want to get back into some coding. So this is what we're going to look at now, the state engine. So what is a state engine? Well, I'm not great at descriptions, so this thing is to describe it as it's a series of states that you can fall into based on all your equations, all your conditionals, all those variables coming together. You've checked a few things and you want outcomes based on a certain thing. For example, if the player was pushing forward in a character control, you'd want to walk forward. But if he was holding the shift while pressing forward, then you'd want a state of running, not walking. Okay, so based on our inputs or all our conditionals, we determine an action. And then in our state engine, we're going to apply whatever that action requires. So let's get into it. The example's the best thing. So yes, we are going to create a new script. And this is going to be state engine example. So open that up. Your script editor. So how does this work and how does it look? If you remember back to our conditionals, we would check if a condition, and if that condition was true, we would do something. Or else, if the above condition, if that condition was not true, we would fall down here and we'd check another condition. If that second condition was true, we would then do this. And then you can of course chain these. You're constantly checking on things. Okay, so the first part of the state engine we're going to look at is a switch case. And this operates exactly the same way as that if cluster I was just demonstrating does. Let's comment that out because we'll use that as a point of reference to compare. Okay, so I'm just going to start typing it out and I'll explain it as I go. So we're going to switch. I'm going to switch based on a variable. Okay, we need an input here. We want to make a decision. We want to make a decision in here based on a condition in here. So let's create a variable for that. We'll create a global variable because we want to remember it. And this is just an example, so I'm just going to call it our state variable. Now it's going to be of type integer, so typecast that as an int. And we'll assign it a value of 0 immediately. Okay, so we have our variable that will remember our state. So this is what we have so far. This is like saying if, no, we're going to switch on something based on the condition. Now the if part falls in here. So depending on that variable, it's like saying if our variable is equal to 0, we're going to do something in here. And that's the end of what we're going to do. Okay, let's even put a debug in here. Case is 0. Okay, that's like an if. Let's have a look at what I've just done there. So we're switching based on the value of our variable. So we're saying if our variable is equal to 0, do this. If our variable is equal to 1, we're going to do this. As you can see, it's pretty much the same as an if, or a cluster of ifs. It's just a bit more organized. Instead of all this else if, we just have different cases. So the main thing is we're not checking through each one of these else's. If we had a cluster like this, we check for this, no. Then check for this, no. Then check for this. And then you fall to the bottom, else nothing was true. Let's do that. Okay? We're not checking everything every update. We just say here, okay, we only want to jump to the case based on the value of our variable. Okay, so it's already a little bit more efficient. As you see with our if clusters, we had a condition right at the very bottom. If none of the above was true, else we're going to do this. We have that in our switch too. Basically, if there's no case, we set a default. Great. So if our switch variable is 0, 1, 2, or 3, we'll do these, which I should change. Let's make it different. Let's mix it up a bit. And by default, if none of the cases are true, we fall down to the default. So there we have it. Basically the same as an if cluster, but written out as a switch and far more efficient. So let's see what we can do with that. So we've saved that out. Let's go back to Unity, check for any compilation errors. Great, no. I've got our timer script here. Alright, let's create a new scene. And let's save that scene. This is our state engine. Okay, I'm just going to create an empty game object to attach our scripts to. And we'll attach our script to that empty game object. So here we can see our variable. Let's just hit play. So there we go. Cross-reference to our script and see what's happening. So, let's see, if our variable is 0, we're falling into case 0. And then we check our console, and it's reflecting that indeed. Let's see if I can get everything on the screen at once. So there we have it. We have our variable, currently is set to 0. So this is saying if our variable is 0, we're going to output this to the console. And here we have it. So let's just continue testing on that. Let's change our variable in the inspector. Let's jump to 1. Now the case is 1. Let's just cross-reference that. Okay, so our variable is now equal to 1. So we've fallen into this case. We're only going to apply these actions. And then to continue testing, 2. Now case is 2. We can jump all the way back to 0. Case is 0. 3. Now I think we only went up to 3, so what happens if we fall? Even before it goes, no cases are true. Let's cross-reference that. So that's what's happened. We've come to our switch. We said switch based on the value of our variable. None of these were true. The value of our variable was neither 1, 0, 2, or 3. So we fell into our default. And we can check that again. I said we can put in 1000. We don't have a case for 1000, so none of the cases are true. Okay, let's clear the console and just prove that again. So let's put in 20. No cases are true. Bring that back down to one of our cases. Our case is 3. Okay, fantastic. So that's pretty much the whole of the first part of the state engine. Great, so we don't even need that reference anymore. We know what's going on here. So even this switch in itself will serve as a state engine. This is already a state engine. See? You've already done it. Okay? As in my description, based on a decision that has been made by several checks and that, we've come to a state. We've said, okay, out of all the things that are happening in our scene, we've determined that this is happening. We could be walking, we could be running, we could be jumping, we could be falling. Okay? These are all the different states that you can be in. Currently, it's only working numerically. How can we make this a little bit easier to read? Now, we're going to introduce something new, and that's called an enum, an enumerator. Now, I don't know how to technically describe this, so I'm going to bring it into an example. Okay, so just say we have a variable. It's going to be a boolean. So it's going to be of type boolean. If I can spell. Okay. So we know in a boolean we can have two states. And there's that word again, state. Okay? So we know a boolean will always return true or false. Now an enum, or enumerator, is like creating your own variable. Just like the boolean, we've said there are two states within the boolean. We can create our own variable. Let's do that. No, this is an enum. Okay? Let's set up a little bit differently. Now, enum, we're going to give it these different values like true or false or walking, running, jumping. Okay. Usually you have a default, and I usually put it up the top, idle. Okay, nothing else is happening. It's in a rest state. And there we have it. Now, we haven't given our newly defined variable a name. So let's give it a name. My enum. Just as an example. Of course, your naming convention will be better when we get into actually programming it specifically. Okay, so we've created an enum, given it a name. We said, okay, our enum has 4 states. And our 4 states are idle, walking, running, or jumping. Okay, so this is an enum. Now we create a variable, just like above here, to store our enum. So actually, we could even take that one and let's just rename it. Okay, so state, well, it's not a matter of renaming it. We now have to typecast it. Okay, so we've created a variable, kind of, and we have to typecast to that. So we're going to typecast it to the name. There we go. So basically, our state variable is going to store our enum. And our enum currently has 4 values. Okay? Let's see if we can set that up. So now our variable has changed from an integer to an enumerator. We have to change our states. So we're looking for my enum dot. Great. It's already come up in the autocomplete. So what are we checking here? We're checking our variable, and we're saying here, if our variable is equal to our enum idle, then we are indeed idle. So we can just run through with all the rest of these. We have walking, we have running, what else we have? Jumping. Let's even put in another one. You can see how handy an enum is. Remember, we need to separate all our different states of our enum with a comma. except for the last one. Okay. What else have we had in here? Jumping. Now you see we haven't included a case for falling. This is just something I wanted to demonstrate our default working. So that's why I threw in an extra one. Let's save that out. Check for compilation errors. No. Let's check what the enumerator has done to our variable. So we have our state variable, but now we see we've got all these different states. Okay? So instead of just using 0, 1, 2, or 3 and trying to remember that 0 was idle and 2 was running, we can actually give it our own names. Much easier to follow along. Now let's playtest that. So our case is idle. Let's change it to, and there we go. You can see that I didn't even update that script. And just so our debugs do reflect our state, we'll update those, save it out, go back to Unity, let it compile, clear and reset, let's go again. We have a case at idle. What happens if we're jumping? That's reflected. Walking. Now what if we fall into one which we didn't give a case for? What we're falling into falling. No cases are true. We cross-reference that. Yes, we don't have a case for falling. So great. So there it is. That is the basics of a state engine. That's how it's set up. That's how it works. So somewhere along the line, you're going to make some decisions and some choices, and then you're going to say, okay, my state has fallen into one of my preset states. I know then, if I'm walking, I want to do walking things only. Play a walking sound, play a walking animation, move direction, calculate speed and direction of travel. Anytime we're walking, we're only going to be doing things in here. That's about it.